Hello, we are now on the next chapter of our lessons in Math 9. This will be all about variation. Um, every year in February, Pampanga Clark Freeport plays host to the Philippine Hot Air Balloon Festival, gathering aviators and spectators from around the world for about 4 days of non-stop flying action. Why does a hot air balloon fly? It flies when the air inside the balloon is less dense than the air surrounding it. The heated air inside the balloon makes it buoyant since it has a lower density than the cooler air outside the balloon. Many things in life vary directly or inversely. Air pressure decreases with increasing altitude and increases the deeper one dives. So today we will be focusing on direct variation. Our objectives: first, to illustrate situations that involve direct variation. Second, translate into variation statement a relationship involving direct variation between two quantities given by a table of values, a mathematical equation, a graph, and vice versa, and solve problems involving direct variations. All around us, some quantities are constant and others are variable. For instance, the number of hours in a day is constant, but the number of hours of daylight in a day is not. Now, you will explore more closely certain types of relationships between variables. Okay? Sometimes changes in the values of two variable quantities can be related. When a change in the value of one quantity corresponds to a predictable change in the value of the other quantity, then we say that the two quantities are related. Let's begin by examining some related quantities in very familiar situations. We have number of hours spent on social media and number of friends, socioeconomic status and IQ, nature of activity and heartbeat, and hard work and success. Which of the following quantities do you think are related? Alright, arguably, except for time spent on social media and number of friends, and socioeconomic status and IQ, the other pairs of quantities or variables are related. Why? For instance, the nature of activity and heartbeat are related because yung tibok ng puso mo depende sa nature ng activity mo. Kung at rest ka, your heartbeat is normal. Kapag nagtatakbo ka, nag-exercise ka, bibilis yung heartbeat. So they are related. Alright? Before we proceed to the definition of direct variation, let us first define what variation is. Variation is defined by any change in some quantity due to change in another. We often come across with different types of variation problems in mathematics. Variation problems involve fairly simple relationships or formulas involving one variable being equal to one term. And as we go on along with the discussion of variation, we will be dealing with different types of variation. Alright? One of those is direct variation, which is our lesson for today. The second one is direct square variation. We also have inverse variation, joint variation, and combined variation. So those types of variation will be discussed later on. Okay, I have here a function, an equation y equals 3x. Let us complete the table of values. What is the value of y if x is 1? So just simply substitute the value of x to the equation. So if x is 1, 3 times 1 is 3. Y is equal to 3. If x is 2, y is 6. If x is 3, so 3 times 3, we have 9 as the value of y if x is 3. If x is 4, 3 times 4, y is 12. If x is 5, 3 times 5, y is 15. And if x is 6, y is 18. Notice that as the value of x increases, the value of y also increases. As the value of x decreases, the value of y decreases. So the relationship between the values of x and the values of y in this example is expressed by the equation y equals 3x. So the equation is called a direct variation. We say that y varies directly as x. There are so many quantities that can increase at a consistent rate. Halimbawa, if you set your car's cruise control and start driving, you will travel a consistent number of miles per hour every hour. If you save the same amount of money per week or every week, you will increase your savings by a consistent amount. Okay? In direct variation, two quantities such as halimbawa, time and distance or hours and pay increase or decrease at a consistent rate. The consistent rate of increase or decrease is also called the constant of variation. There is no formally defined direct variation. Direct variation is a relationship between two quantities such that an increase in one corresponds to an increase in the other at the same rate, or a decrease in one quantity results in a decrease in the other quantity. The general equation of direct variation is y equals kx, where k is the constant of variation and k should not be equal to 0. Alright, the general equation for direct variation is y equals kx. For us to solve for k, or for the constant of the variation, we just simply divide both sides by x. Okay, and then x must be cancelled. And then what's left is k equals y over x, or k is equal to y over x. So this is the formula used to determine the value of the constant of the variation. Let us now determine if the given table of values is an example of direct variation. If so, determine the value of k and form an equation that satisfies the given condition. Since the value of k, or the constant of the variation, is given by k equals y over x, we can easily identify the k for each. So we have 1 over 2. Y over x is 1 over 2. In this example naman, we have 2 over 4. 2 over 4 when simplified is 1 half. Here, our y over x is 3 over 6. And 3 over 6 is also 1 half. In here, y over x is 4 over 8, which is also equal to 1 half. Since the value of k in each are the same, k is equal to 1 half, we can say that yes, y varies directly with x. This table of value is an example of direct variation whose equation is y equals 1 half x. Y is equal to 1 half x. Y is equal to kx. Our k is 1 half. So therefore, the equation is y equals 1 half x. Next example. Determine if the given table of values is an example of direct variation. If so, determine the value of k and form an equation that satisfies the given condition. First, let us identify the value of k, y over x. Y over x in here is 3 over 1 or 3. Second, we have 5 over 2. Third, we have 7 over 3 or 7/3. And lastly, we have 9 over 4. Notice, hindi pare-pareho o hindi magkakapareho yung value ng k. So definitely, the ratio or constant is not the same. We can conclude that y does not vary directly with x. In other words, the given table of value is not an example of a direct variation. Y equals kx in mathematical statement is read as y varies directly as x. Okay? Y varies directly as x. So if we translate r varies directly as j into mathematical equation, we can say that this is r equals kj. So if you say this, ang basa dito, r varies directly as j. Next, m varies directly as d. So this is m equals kd. M varies directly as d. Next, we have f varies directly as p. That is f equals kb. Alright? So let us now solve the given problem. So given y varies directly as x, the question is, if x is 3 when y is 15, find y when x is equal to 33. So yes, we will be following 3 steps. First, you have to transform the mathematical equation y varies directly as x into an equation. Second, you have to find the constant of variation, that is k equals y over x. Y over x if the given variables are x and y. Okay? And for the last one, you have to solve for the unknown value. Alright, let us start. The first step, transform the mathematical statement into equation. Y varies directly as x. Alright, so that is y equals kx. The constant of variation is given by equals y over x. Our y is 15 and our x is 3. So definitely this is 15 over 3 or 15 divided by 3. And then the value of k now is 5. Third step, since we are asked to find y when x is equal to 33 and given the value of k which is 5, using the original equation y equals kx, we then substitute the values of x and k. The equation becomes y equals 5 times 33 and then y is equal to 165. Y is 165 when x is equal to 33. C varies directly as b. If b is equal to 5 when c is equal to 10, find c when b is equal to 4. Okay, first step, transform the mathematical statement into an equation. C varies directly as b. That is c equals kb. C equals kb. Now, let us find the constant of variation. The constant of variation now is given by k equals c over b. We divided both sides by b to remove b here, to isolate the variable k. That's why the formula to find the constant of variation is k equals c over b. Our c is 10, our b is 5. So that is 10 divided by 5, and that is equal to 2. The constant of the variation now is 2. And then let us perform step number 3. solve for the unknown value. Find C when B is equal to 4. Again, we will be using the original equation, C equals KB, to solve for C when B is 4. Since our K is 2, we substitute, no? C is equal to 2 times 4, and C is equal to 8 when B is equal to 4. Alright, you try this. You may pause the video, and afterwards, once you have already answered this, you may play the video. Alright, let us answer. One of the solutions of y equals kx is 3 and 51. Substitute the values of x and y. We have 51 equals k times 3. Solve for k by dividing both sides by 3. And k is now equal to 17. The constant of variation is 17, and the equation of the variation is y equals 17x. Next, another one. Again, you may pause the video, and after you have answered this, you may play the video to reveal the answers. So given y equals kx, substitute the values of y and x. Y is 24, x is 6. Therefore, k is 4. So this is the constant of variation. Y equals 4x. This is the equation of the variation. Substitute 15 for x. Y equals 4 times 15. And then solve for y. Therefore, y is 60 when x is 15. I hope you learned something today. Thank you.